Hello, hi friends. Today I am discussing about the numerical integrations. So, as we know, uh, in class 10 and 12, that means in plus 1 and plus 2, we have done integrations, but this is different types of way by which we can integrate. Okay, so in numerical integrations, in generally, there are three rules are there. More than three rules are there, but uh, mainly popular three rules are: first one is the trapezoidal rule, second one is the Simpson one third rule, and third one was the Simpson 3/8 rule. So I will show how directly I can say the rules, but uh, I will show the derivations of the trapezoidal rule, then Simpson one third rule. Okay. So what is numerical integrations? So numerical integrations means, suppose this is x-axis and this is y-axis. Suppose this is a curve, y is equal to fx, and if I want to find the area of these portions, suppose this is these portions, okay, then we have to integrate these things. Now this is the x-axis, so this is, we can say, this is the origin 0 0. We just consider this is x0. Now what we have to do, we have to divide this space into equal interval. That means this is x0, then next part we can say this is x1, then next part this is x2, then next part this is x3, dot dot dot, up to this is xn. So the condition is what we have told, this we have divided equal part into this space. That means x0, this is, we are considering this is x0, then this is, next is the x1. So as this is all equally spaced, that's why we can say this is x0 plus h. So this will be x0 plus 2h, this will be x0 plus 3h. So definitely this will be x0 plus nh. Okay, now we have to integrate this part. So the integration is integrations. So what is the starting point? Coordinate is, this is the x0, and the upper part and the end part is the x0 plus nh. So that's why you can say this is the lower limit and this is upper limit, and the function is fx dx. Okay, now we will substitute x. So we can say let x equals to x0 plus rh. We are substituting x. So x equals to here x0 plus rh. So dx will be definitely h into dr. Here h is the constant part. So as we substitute, so definitely the limit will be changed. So x is so when x equals to x0, so the value of the r will be 0, and when x equals to x0 plus nh, so r will be n. Now the integration becomes 0 to n f of x0 plus rh, and dx will be h will be here, that is dr. Okay friends, so we are substituting x equals to x0 plus rh, so definitely we are derivative doing differentiate x, that is dx equals to h dr, and limit already the limit the value of the limit will be changed. When x equals to x0, r will be 0, and when x equals to x0 plus nh, r will be n. Now we are using the Newton's forward interpolations formula. So this is 0 to n. So as we know, the Newton's interpolations formula, this is f of x0 plus rh. This will be y0 plus r into delta of y0 plus r into r minus 1 by 2 factorial del square y0 plus r into r minus 1 into r minus 2 divided by 3 factorial into del q y0 plus dot dot up to this dr. So the next part is okay. So next part is we have to integrate this part. So h we have to integrate, that means this will be r into y0 plus r square by 2 del y0 plus half into r cube by 3 minus r square by 2 into del square y0 plus and the one will be 0 to n, and this will become n y0 plus n square by 2 del y0 plus half into n cube by 3 minus n square by 2 into del square y0 plus it will continue. So this is equation number 1, and this equation is known, this equation is known as Newton's Cotes quadrature formula. So this equation is known as Newton-Cotes quadrature formula, and this is very important formula, because from this equation we will get these 3 rules. First is the trapezoidal rule, second is the Simpson 1/3 rule, and third is the Simpson 3/8 rule. There may be another so many rules are there, but these 3 formula is very important. Most of the in BTech syllabus and MCA syllabus, mathematics honors syllabus, Mainly these three rules are in the syllabus. Okay, so first we will show how to derive the trapezoidal rule. So if we put n equals to 1 in Newton Cotes quadrature formula, and passing the curve through x0 y0 and x1 y1, so that difference of order higher than 1 may be ignored. So what I told, this is the Newton Cotes quadrature formula, and this is very important, and the significance is from this equation we will get trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule, another rules is Boole's rules are there, so many rules are there, but we are here discussing about the mainly these three rules. Okay, so how we will get the trapezoidal rule? We have to write this way. If the in the examinations derivations also come, so if derivations question is like that, derive the trapezoidal rule, so we have to do from the beginning what we have done over here. Okay, these things, then this we have to first derive the Newton Cotes quadrature formula, then we have to write this like this way. Put n equals to 1 in Newton Cotes quadrature formula and passing the curve through x0 y0 and x1 y1. Why? Because there is so many here we will say x0, x1, x2, x3. So we are considering only these two coordinates, passing the curve through x0 y0 and x1 y1, so that difference of order higher than 1 may be ignored. So here we are here we see there is a, this is the difference of order del y0, that is difference of order 1, and del next part is the del square y0, and if we write the next part, then there will be del q y0. So we are taking only the difference of order 1. Okay, are you getting? We are considering only difference of order up to 1. So here we are writing, we are passing the curve through x0 y0 and x1 y1, so that the difference of order higher than 1 may be ignored. We are taking only the difference of order up to this. Okay, next we will proceed. Now so left part is the integration x0. What is the actual left part? Actually integration is the, this is x0 to x0 plus nh. So this will be x0 to x0 plus, what we have done, we told here n equals to 1, that means x0 plus h, fx dx. Okay, and the right hand part is h into n equals to 1, that's why this is y0, and this part will be 1 by 2, so 1 by 2 del y0. Now we will simplify h y0 plus half, and del y0 we know from the difference formula, that is y1 minus y0. So we simplify, that will be h by 2 into y0 to y0 plus y1 minus y0, and finally this will be h by 2 into y0 plus y1. Okay, so here we see this is integration x0 to x0 plus h f of x dx equals to h by 2 y0 plus y1. So this is suppose equation number 1. Now if we proceed like this way, same, we can say x0 plus h to x0 plus 2h fx dx equals to h by 2, and this will be h y1 plus y2. If limit, lower limit is x0 to x0 plus h fx dx equals to h by 2 y0 plus y1. So similarly in the next part, next interval, lower limit, if we take the lower limit x0 plus h and upper limit is x0 plus 2h fx dx, definitely this will be h by 2 and this will be y1 plus y2. And what will be the next? If we take lower limit x0 plus 2h and upper limit x0 plus 3h fx dx, this will be h by 2 into y2 plus y3. So if we proceed like this way up to in the last steps, so lower limit will be x0 plus n minus 1h and upper limit is x0 plus nh fx dx, this will be h by 2 and this is a yn minus 1 plus yn. This is equation number n. So adding the above all the intervals, so adding all the integrals, we will get, so first the lower limit is x0 and the last upper limit is x0 plus nh fx dx. Here we will see in the first equation number 1 h by 2, all the in the all intervals right side is the h by 2, so h by 2 is the common. And now here you just see y0 then y1, in the next part y1 plus y2, next part y2 plus y3, and the last part is y1. So you just notice y0 and y1 is the single, so we are writing y0 plus yn plus all the y1 over here, and in the next intervals there is y1, here is the next part y2 then y2, so this will be 2 into y1 plus y2 plus y3 plus y4 plus dot dot up to yn minus 1, and finally this is called the trapezoidal rule. Okay, so you can say what is the significance of this trapezoidal rule, because in class 11 or 12 or plus 1 plus 2 we have done integrations using several types of, by substitutions, by various types of formulas. So here the main difference is that if this function is complicated, by something is very much complicated, then any type of function, in case of any type of function, we can use the trapezoidal rule, because there is some limitations in particular formulas what we have done in the class plus 1 and plus 2, that means 11 and 12. But here main tricks is that this is the function, and this function, if there is this function is very much complicated, that we can't use the substitution rules or the formula we have done in the class 11 or 12. But here this is the process is something different. So are you getting what is the main significance of the trapezoidal rule? In case of any kind of function, it may be complicated, it may be mixed functions, we can use the trapezoidal rule, Simpson one rule. But there is a little bit of error. So this is trapezoidal rule. Now we came to the next formula, that is the Simpson 1/3 rule. So we will proceed in the same way. We have done the trapezoidal, the derivations of the trapezoidal rule. Here we just we will show just the initial part of the Simpson 1/3 rule. You can do yourself. Same things, same procedure. Just we have to put n equals to 2 in quadrature formula, and passing the curve through x0 y0, x1 y1, x2 y2. So here we are adding one more coordinate, so that difference of order higher than 2 may be ignored. Same thing, and we will proceed in the same, like this, same way, and finally we will get x0 to x0 plus nh fx dx will be h by 3 into y0 plus yn plus 2 into even term, that is y2 plus y4 plus y6 plus up to yn minus 2, and 4 into the odd term y1 plus y3 plus y5 plus up to yn minus 1. So this is the Simpson 1/3 rule. If we proceed same way, okay friends.